It's recording? It's recording. Okay. Alright. Good job, Sam. Thanks for that. Okay. Alright. The silence is just nerve-wracking. What am I doing? Alright, that threw me off. B. You guys, that B, are all those B's okay? Just cursive. Okay. Alright. A, B, B. Here we go. Sweet Jesus. X plus 1 over x minus, I lied, x plus 2 over x minus 1 greater than 0. Alright, I already told you, you can't clear fractions, okay? As soon as you see that symbol, you need to stop. Okay? It should just ruin your life. Okay? If every time you see an inequality, you have to stop and think about it. Don't clear fractions, sweet Jesus, don't clear fractions. So, is this linear? Nope. Because there's an x in the denominator. So we need a sign chart. Okay, that's like your brain process. Every time you see a less than or greater than symbol, you have to like stop and think. Okay, please don't clear fractions. So we have to start with, is it set to 0? Yes, because remember, a number line is comparing to the number 0. So if it's not set to 0, you're not comparing to 0. It's set to 0. Then you got to label your crap. It's like, well, what is my crap like? What is my sign chart based on? It's based on the stuff to the left of 0. What are we trying to make greater than 0? We are trying to make this crap, x plus 2 over x minus 1 greater than 0. All of your information comes from here. I promise you've labeled this. I promise you when we come back on Monday, you'll be like, oh, Sam, you were right. Oh, my goodness. Do this. Okay? All right. What is this called? Zeros. You set the entire crap equal to 0. Some people, my little lovely 1050 guys, like set the numerator equal to 0. By definition, it is when the whole thing equals 0. Now, does sometimes just setting the numerator work equal to 0? Yes, but that's only certain times, so I don't want you to screw it up. Set the whole thing equal to 0. Alright, x plus 2 over x minus 1 equals 0. And then now what? How do I do that? How do I solve this equation?
Aren't you going to find the zeros and prime numbers?
Yep. So we're finding zeros right now. Set the crap equal to 0. Now you can clear fractions because you have an equation. So we could not clear fractions here because we had an inequality symbol. We can clear fractions here because we have an equation. That's why you're clearing fractions now. So when you multiply both sides by x minus 1, I'm never going to show this stuff after this, just the FYI. But this is what happens. You clear the fractions, the right side still equal to 0 because anything times 0 is 0. So that's why it looks like, oh, just set the numerator equal to 0. That's not always the case, and that's not the definition of a 0. Okay? So please be careful.
So didn't we start off with an inequality?
Yeah, but since we're oh, I'm glad you said that. Since we are now looking for zeros because I have properly labeled my work, by definition, it's an equal sign. That's the only way, so I'm glad you said that. That's the only way this problem, which was a greater than symbol, turned into an equal sign because we've labeled it as we're finding the 0. So by definition, it's equal to 0. That's the only reason we get to change this problem, is because we're using the definition of a 0. Okay, so glad you pointed that out. So x equals negative 2. That means when you plug in negative 2 into this whole thing, it makes it equal to 0. Okay, that's what that means. Now our bad numbers. Does your crap, x plus 2 over x minus 1, have an x in denominator?
Yeah.
Yep, yes. So you have bad numbers. And if you remember by definition or undefined, probably if you were in a Russia's class, your, what is that called? Domain issues. So in just looking at this expression, okay, forget that it was an inequality, equation, it's not a function, I don't care. Just this thing, if I wanted to plug in a number, can I plug in any number I want? No, because there's an x in the denominator. So your domain restrictions are, when there's an x in the denominator, it cannot equal 0, okay? So you set your denominator not equal to 0 and solve. So this, by definition, your bads or your undefined is just the denominator. Okay? x minus 1 cannot equal 0. So x cannot equal the number 1. When you plug in the number 1 into the entire crap, it makes the bottom 0. So, however you solve this problem, 1 cannot be in your solution set. You plug in 1 into that. If you plug in 1 into that, that does not make a true statement. It doesn't even make a number. Okay? So we got to exclude that. Alright, so now we have our zeros and our bads. I'm going to start on a new sheet of paper just because I know I'm going to have work to do. What time is it? Lord. I got to give you guys a break. Give you a break or end early?
End early.
And early.
Okay.
Yeah, end early.
We don't care about your back, Sam. You don't need a break. Whatever.
I mean, you could take a break and class early.
Y'all had a break when I was having technical issues. Get out of my face. Alright. So. Sign chart. I like to color coordinate over here. My sign chart is for my crap. What's my crap? X plus 2 over x minus 1. Okay. And these are my x values. And they are negative 2 and 1. So negative 2, 1. Okay. Alright. And when I plug in these x values, when I plug in negative 2, I get out 0. And when I plug in 1, I get a bad number or undefined if you're a little rushy, whatever. Okay. Now we got to find out what happens when I plug in the other x values in these intervals. So we got to pick other x values. Water. I could be drinking liquor in here. You guys would not even know. I'm not. Let me say that in my video. I'm not. Okay? You would probably know. Alright, x equals, you want to pick a number?
Negative 50.
Negative 50, good job. Say 50, nice job. X equals 0. X equals? Somebody say it.
75.
Good job. Alright, so, little preview for one of the next examples we're going to get in. It's nice when you have just one fraction you're plugging in, because then you can just look at the signs. So, x equals 0, or I lied, x equals negative 50. Oh my god, my pencil. I'm going to use so much lead, and I'm going to have carpal tunnel by the end of the summer, promise. Negative 50 plus 2 over x. I don't know why I'm looking at the screen, but whatever. Chingo. See, I do need a break. I can't even think. If anybody knows what that means. Negative 50. Negatives.
You liquor in the water bottle.
I swear. I swear. Like, have I ever gone to work under... No. I wouldn't be able to function. I would just... Either I wouldn't be able to function or I would dance. I don't know how people... I don't know if any of you guys smoke, but I don't know how people function. I don't know how to do that. I don't know. That's insane to me. Anyways. Squirrel.
Yeah. Does this work, or can we just put, like, the negative sign over the negative sign?
Yeah, I'm cool with that. Like, so that works
Okay.
because it's division. So when it's multiplication, like my two factors, so you're just looking at what times what signs, and division is what divided by what gives you a sign. That's why it's nice to have one fraction. So I'm cool with that. So you get out a positive. Oh, color coordinating. When you plug in 0, you get it 0 over 2, 0 minus 1. You get a positive over a negative equals negative. You guys see, is that cool? Positive divided by negative. So just signs. That's all I want are signs. And then when you plug in 75, in your head, like you're looking at like 75 wins. Positive over positive. That's why 75 is nice. Same with the negative 50. 75. I'm trying to fly. I'm trying to fly. Who's messaging? I'm doing all this work just for the first set of notes, and the rest of it, like, we're going to fly through, like, all that work. Positive. Alright. Just a little FYI, you guys should already know and not assume that it doesn't always alternate. And here's some good news. In possibly a few weeks, I don't know, I'm going to show you a shortcut to sign charts where you never have to plug in a bunch of numbers ever again. But not now. Alright. So, we have our sign chart complete. Our original problem said, crap, x plus 2 over x minus 1 is greater than 0. Greater than 0 means what? Was
Positive.
positive only. So no equal to 0. So that means we don't want to count this little 0. And you never count your bad number because that makes it undefined. Okay, so this is going to be an open circle. And not, just FYI, not all teachers shade like Resh and I do. Like shade this number line, just the warning. Okay. Open circle on a bad number, you never include that. Okay. And we want all the x values that give our y values, or this thing, our crap, positive outcomes. So what interval or intervals are those?
Negative infinity to negative 2.
Good. Anything else?
And then the U thing and 1 to positive infinity.
The U thing, our union. So negative infinity to negative 2, soft bracket not included. Union that joins those two sets of answers together. 1 to infinity. The direction somewhere, I'll fix it before I scan it, should say writing your answer in interval notation. Alright, give me questions, comments, concerns. Complain a little bit, not much. Not much. I'm just looking at my notes, what I want to do next. Alright, here we go. A, B, C, D. C, we're on C? Sweet Jesus. Speed it up, Sam. Let's go. Alright, x squared is less than 3x. Try that one, all on your own. Go. I'm gonna take attendance again, sweet Jesus. See who left me. What do I have? I have 34. Let's see what happened. Alright, it's going to be way easier if you just say here when I say your name than me trying to look for you. Okay, so I'm going to take attendance again. Caden? Caden? So FYI, I'm going alphabetical order, so you know when your last name starts. Shahani?
Here.
Thank you. Batul?
Here.
Elena?
Here.
Russell? Megan?
Here.
Ayana?
Here.
Marwa?
Here.
Ved?
Here.
Addie? Hala?
Here.
Okay, I'm like, I saw you. Cece?
Here.
Muhammad?
Here.
Fatima? Fatima? No Fatima? See, look, I lost one. Fuad?
Here.
Thank you. Mason?
Here.
Allah?
Here.
I have two.
Barshi.
Okay, hello. I didn't realize you were here too. And then Jafar's here. Okay. Jamie?
Here.
Stephanie? I don't think Stephanie came in. So upset about that right now.
Did you hear me when I said here?
Where? Who was the speaking?
Fatima?
Oh, no, I did not. Oh, good job.
Oh, I said it a few times, but I guess I was.
It was broken up, but then I didn't know if that was somebody else because I didn't hear a clear voice. Alex?
Yeah,
oh, sorry.
Good, but here.
Chris?
Here.
Bruno?
Here.
Elizabeth?
Here.
Diana? I saw it. I saw you.
Here.
Sydney? No Sydney? Matthew?
I'm here.
Luis? Sahara, I saw you.
Here.
Samar?
Here.
Ramsha? Rafat? Where's
Here.
Rafat? Huh. Horace? I know I saw
Here.
you. Okay, I'm like, I know I saw you. Rayanne?
Here.
Sophia? I thought Sophia came in and then went out and then came in. Sophia, you here? No. Jesse? You didn't come in either. Alright. Let's hope you guys. I don't leave anybody else. I don't have to do that ever again. Alright, what'd you guys do? Divide both sides by X or what?
You didn't call my name. I don't know if that matters.
Oh, maybe I just knew you were here, or maybe I think I said it, and I think Fatima started talking, or Fatima started talking, and then that was it.
Well, I'm here.
Did you divide both sides by X, right? Is everybody cool with that? Divide by X? Okay,
No.
good. Okay. I thought I was going to smack somebody
Yeah.
virtually. Okay, good. Don't do that. You got to set it to 0. Why do I got to set it to 0?
Because it's an inequality and you have to.
It's a nonlinear inequality. Because it's a nonlinear inequality, I don't know if I spelled that right, I didn't, whatever, I don't care. You got to do a sign chart. And in order to do a sign chart, you got to set it to 0. So that's your train of thought. As soon as you see the symbol, you're just mad. Okay, you got to stop. So you were setting it to 0 because it's a nonlinear inequality and you have to do a sign chart. So that's why you're setting it to 0. All right. And then once it's 0, then you label your crap. Your crap is x squared minus 3x. That is the stuff to the left of 0. I keep everything on the left. It's easier to understand. If you want to factor your crap right away, I don't care. Just know that this is the stuff you're going to get all your information from. Okay. Let's keep moving.
On our tests and homeworks, we have to label it as crap.
Nope, but don't screw it up. That's all. You do have to label your zeros and your bad numbers.
Okay.
Yep. All right. You set your crap equal to 0 for your zeros. That's the definition of a 0. If you already factored it, sweet. Again, you get to factor it because it's an equal sign. Notice I'm flying because that math should be like, once you get an equation, it's like, oh, that's easy. We learned that 7 years ago. Okay. For your bad numbers, crap has no denominator, or x in denominator. So, none. You have no bad numbers. Okay. So then you got your sign chart. Bam. Your sign chart is on your crap of x times x minus 3. Okay. Or the other version, whatever version you want to use. You just have to use all of it. Don't lose any pieces of it. And you get 0 and you get 3. These are zeros. So now I'm just going like my color coordinating had stopped. Sorry. Alright, these are your x's, these are your y's. So pick a number, x equals negative 75, x equals 1, x equals 27, whatever. Okay. And then if you plug it into the factored version, it's pretty easy. Negative 75 times, either version doesn't matter. Negative 75 minus 3, that's a negative, and a negative gives you a positive. Okay. And then you do all that work and you're like, negative, positive, negative. Because Sam knows a shortcut. You'll learn that later. Okay. Is that what you guys got? Ah, chinga. Is that what you guys got? Yes, no, maybe so. Good. I see that shaking. Thank you.
Yes.
Alright. So, what do we want? What does our stuff start off with? We said x squared minus 3x is less than 0. So what do we want?
The negative
The
part.
negative. Negatives only.
Quick question.
Yes.
If we don't have any bad numbers, like for this one, do we have to say there are no bads, or can we just act like they don't exist?
That's a good question. I mean, it's fine. I guess if you don't, that's fine. It's 1800. 1050 I would probably make you. I want to make sure you're thinking about everything.
Okay.
Alright, so those are the x's that give you negative outcomes or outputs, however you want to say it. Not including the zeros because there's no equal sign, so I have 0 to 3. Bam, done. Okay. Questions, comments, concerns, no complaints. Alright, A, B, C, D. D? Yeah. 3 minus x over x plus 4 is less than or equal to 1. I'm going to start this one. I'm not going to finish it, just FYI. Just to show you the nice, you know, what you can do, what you don't have to do, options and all that stuff. And then I'll let you guys, like, not go. Let you do whatever you want in this problem. Alright. 3 minus x over x plus 4 is less than or equal to 1. So, where do we start?
Subtract 1.
Alright. If somebody says declare fractions, I'm going to hurt somebody. So this is nonlinear because why? What makes this thing nonlinear? X in denominator.
Equality.
X. So x in the denominator in an inequality, not just because it's an inequality. So be careful because we have other inequalities we don't have to do this stupid process with. X in the denominator in this inequality. Okay, so we got a sign chart. And we got to set it to 0. So good job. So 3 minus x over x plus 4 minus 1 is less than or equal to 0. Now we are comparing to the number 0. That's what a sign chart is all about, comparing to the number 0. Also, technically right now, you have your crap. Your crap is everything to the left of 0. It is 3 minus x over x plus 4 minus 1. Like, that is all of your crap. Everything to the left of 0. But you don't have to do this, but it's helpful to do this now. It's going to help you out later. You can actually get a CD and clean up your crap, okay, if you want. So if you want to combine this into one expression instead of two separate things, you can. It'll help you later. So if you get a CD, that's really 1 over 1. Okay? So it's 3 minus x minus, now if you get a CD, you got to go with your CD work, minus that because your CD is x plus 4. So when you get all that, 3 minus x minus 4, you get negative 2x minus 1 over x plus 4. So your crap can either be this guy or a condensed version. The condensed version is nice because when you go to plug in values and check, whoever is not on mute, it sounds funny. When you go to check your numbers, it's nice to check in here because we have one fraction and you could just do the negative over the negative. If you go to check in here, you actually have to figure out this number minus 1 and see if it's negative or positive. So there's a lot more arithmetic going on here. That's why I'm saying it's nice. Not all teachers do this. You don't have to, but I'm telling you the option. It's nice to combine your crap into one expression. Okay? It's up to you. So then from there you get your zeros and your bads. And then go. I'm not going to finish it. Zeros and bads. So your crap is either this guy or it's this guy. It's the same expression. One's condensed. That's all. Okay? And then go. Do sign chart. So that's nonlinear inequalities. I took way too much time on that. I don't care because it's not going to go anywhere. It's coming back. I promise. Remember I said that. Questions, comments, concerns, no complaints.
Do you have the final answer for it, just in case we do it later?
Oh, come on. So yours, that's a good question. Oh yeah, I lied. I do. Good job, good job. I have it already written down over here. Stop it right now. Okay. I was about to do it in my head, and then I have the notes. So there's your final answer.
Thank you.
You're welcome. Thanks for asking. I forgot I had it. Alright. Moving on. What time is it? I have to hurry this up in like 25 minutes. Yay. This is, I'm trying to get a different color. Stop it right now. There we go. 2.1. Functions. So your quiz, even though I've said this, but just make it clear, is on 1.5 and 1.8. It's on the review as well. 1.5 and 1.8. That's what your quiz is on. So even though we're learning starting functions this week, I'm not going to put it on the quiz next week. 1.5 and 1.8 is plenty. Trust me. Okay. So sign charts. Oh, that's on your quiz. Okay. So here we go with functions. Where's my notes? Okay. I'm going to totally skipping all that. Yep. Just going to skip all that.
So the notes that you posted, the 1.10, that's just for something for us to review, correct?
Yeah, that might come up in the homework. I have not decided if I wanted to put it on a quiz or not. If I do, I will tell you guys. Like if I put it on a test or quiz. So you should just review it just in case. But I'll let you know. I won't like put it on there and not tell you.
Okay.
I will. Let me give you the definition of function. I gotta at least do that. But the rest of this intro stuff, I'm skipping all that. So a function is a machine that takes an input and gives you exactly, I don't know why I'm reading my notes as if I don't know this definition by heart anyways, and gives you exactly one output. Really think about and understand this definition. This is going to come up with a lot of different examples. Sorry, I'm checking my phone just in case it's a student. No, it's not. Because we're going to talk about inverse functions, and you got to understand the definition of a function to understand inverse functions and other stuff. So it's a machine that takes an input, so there's your x's, and gives you exactly one output. Outputs are your y's. Okay. So if I plug in 2 and get out 7, and I plug in 2 again, what should I be getting out?
7.
7. It gives you exactly one output. So you can't plug in 2 and get 5 and 7. No, it's no longer a function. Okay? So we're going to talk more about that when we get into inverses. But understand, it takes an input and gives you 7. So, okay, you know what, the teacher and me want to skip this stuff, but I can't. If I plug in 2, I get out 7. If I plug in 2, I get out 7. It does not matter, okay? This is not a function. I plug in 2, I get out 7. I plug in 2, I get out 5. No, okay? One output only. That's bad, okay? This is possible. I plug in 2, I get out 7. I plug in 8, and I get out 7. Oh, okay. So 2 different inputs can give me the same output. That's fine. That's still a function, okay? This is what's bad, okay? These are functions. So this is going to pop more back up when we get into inverse functions, okay? All right, now we're just going to do examples because I don't have time. Let g of x equal x squared plus 4 over 2. So this is all review still, okay? We're gonna finally get into some 1800 stuff in 5 minutes, okay? Find and simplify. So here's A. Find and simplify. Doobie doobie doo. Sorry, I'm reading. This is fine. I lied. G, that's a G function. G of 3 over 5. There's A. Alright, what does G of 3 mean?
You plug 3 into x.
Yep. Plug in x equals 3 into G function. So you got to know this notation. You really got to know it too when we get into inverse functions. So that's the x value. Find y, or the output. Okay. Alright, so you got to know that this means find output. That's the output notation. This notation, G of 3, is an output notation. Okay. Alright, so I'm going to go do that. I'm going to plug in 3. I get 3 squared plus 4 over 2, wherever I see the x. That equals 9 plus 4 over 2, which equals 13 over 2. And then the problem says find G of 3 over 5. Do I plug in 5 into the G function?
No, you divide everything by 5 that you got, like
Yep.
the answer.
Yep. Don't plug into G. It's not G of 5. Okay, so you got to understand the difference in notation. So I think that was Alex that said, alright, G of 3 over 5 is really equal to 13 over 2. That's my G of 2 over 5. Okay. So that's 13 over 2 times the flip 1 over 5. That is equal to 13 over 10. So just inputs and outputs, getting used to functions, all that stuff. So that's that expression. Find and simplify. So you got to know what these symbols mean so you don't confuse them. Got a question, comment, concern, complaint? I had A on that, but whatever. That'll be A. Here's B. Let m of x equal x over x plus 3. Find, so we're dealing with the new function. Find all x such that m of x equals 2. Now I'm asking a different question. Find all x such that m of x equals 2. So you got to know what this notation means. This is different notation than A. Show your face. Who's texting me? Oop. All right. What's that mean? What am I doing?
Set x over x plus 3 equal to 2.
Good. So take your function, set function, equal to 2. Find all x means solve. So what does that mean? Build an equation. So you got to know the difference between m of 2 and m of x equals 2. So, set your function equal to 2. 2 equals x over x plus 3. I don't care how you write it. X plus 3 equals 2, whatever you want to do. Okay? Or whatever. Either way, you're setting the whole thing equal to 2. Okay? And you're solving. You're finding all the x's that make this a true statement. Alright. It doesn't matter. It doesn't matter what you work with. But you're going to clear fractions because it's not an inequality. It's an equation. So I'm going to work over here. X equals 2 times x plus 3. You guys get negative 6. So there's your answer. X equals negative 6. So that guy was finding the input, the x's. The other one was finding the output, the y's. Okay? So just make sure you know your notation. A, B, C.
Shouldn't it be a negative 3?
I minused x over, so that made that 1x. That's what I did.
Oh, okay.
And then I minus 6. Yeah. Sorry, I did a lot of work in my head. Alright. C, yeah, I'm making this C. Let h of x equal x plus 5 if x is less than negative 1, x squared if x is greater than or equal to negative 1. Anybody know what kind of function this is called when it's broken up into more than one function?
Isn't it like a piecewise or something?
Wait, say that again?
Isn't it like stepwise or piecewise?
Piecewise function. Yep. This is a piecewise function. Get comfortable with them. We're going to graph them next week. Right now, we're just going to do inputs and outputs. Okay, so what does this mean? This means that if x is smaller than negative 1, you're going to plug it into this piece of the function, x plus 5. If x is greater than or equal to negative 1, that's a janky greater than or equal to, you're going to plug those inputs into the x squared piece. Okay, that's a piecewise function. It's broken up into two different parts. You're going to, next week when we start talking about this more, get used to like just identifying those pieces. This is a linear function, x plus 5, that's y equals mx plus b. And it's quadratic. Which part?
No, would you say about like the x is greater than?
Okay, yep. So like this is your domain restrictions basically. So if your x values, what you're plugging into the function, is less than negative 1, you're going to plug it into x plus 5. If x is greater than or equal to negative 1, you're going to plug it into x squared. So this is your function if you fall under this category. This is your function if you fall under this category.
Alright,
Cool.
thank you.
And we're going to do more of that next week because we're going to graph and you have to know where to plug stuff in at. Okay, so this is practice for next week. Alright, so there's our piecewise function. Now I'm going to tell you to do some simplifying and stuff. Okay, so here's A. That's a weird, that's a C, and then that's an A. You'll survive. There's A. Find and simplify h of 3. So I'll do the first one, then you guys do the rest. H of 3. So that means plug in 3 into the h function. But which piece are we plugging it into? The top or the bottom?
Bottom.
The bottom
The
one.
bottom.
Okay. So 3 is bigger than negative 1. Right, so that's x is greater than or equal to negative 1. Our x is 3. So it's going to go into x squared. Okay, that's how you figure it out. Is that cool? Alright, so h of 3 equals 3 squared, which equals 9. Ladies and gentlemen, okay, let me do this right now, because I'm going to hurt somebody. Watch. I'm going to hurt somebody virtually. While that's 3 squared is 9, okay, I need to make sure, I may have said this before, but I know I've said it a million times in my teaching career. This, I did say when we talk about quadratic formula, and this are not the same. That's clearly not the same. You need to use parentheses. Anytime you are plugging stuff in anywhere, no matter what you're plugging in, you need to use parentheses. Would it have mattered with this positive 3? No. But for practice sake, those are not the same thing. Okay? Even if you put the wrong work and have the right answer, I'm still taking points off. It's the wrong math, so use parentheses. Okay? You're going to need parentheses when we get into the craziness in a minute. Okay? Alright, so here's B for this problem. So that was h of 3. Still using the same function, do these two. Here's b under c. H of 0, and then c. c. H of... Oh, I lied, you do 3. That's fine. H of negative 2, and then h of negative 1. So you guys do those in the same h function. I'm giving you a minute and a half. A minute, that's 30 seconds per problem. 30 seconds per problem. No pressure. I bought this cushion for my back. I think it's working. You guys are lucky, but I need water. As I'm teaching and you guys are looking at me, although you should be looking at the paper, you see any roaches in the background, you better tell me. You know how many I've killed since I've been here?
That's disgusting that Wayne State has roaches. Just
They
say.
have mice too. Although I'd rather deal with a mouse than a roach. Them things are nasty and huge. I've killed, I don't know, because nobody's here, so they're like, oh, let's roam free. No, that's nasty.
That's actually disgusting.
Yeah, just
Like,
a
I'm
little.
trying to learn there, not fight roaches.
It's disgusting. The first time I was in office hours or workshop or something with my 1050 guys, and it was crawling like right in front of me and up my wall. Oh.
Mm-mm.
And then it haunted me, and then I finally killed it like, I don't know how long later. Alright. Minute and a half I said? Oh, I think you guys got like 10 seconds. I'm a liar. I'm a liar. Alright, so 0 is greater than negative 1. So it's going to go in your x squared, guys. So be careful. Okay, 0 is bigger than negative 1. So when you plug in 0 into your x squared function, you get out 0. Yay, circle box your answer. Okay. Alright, C. H of negative 2. Negative 2 is less than or greater than negative 1.
Less than.
Look careful, less than negative 1. So it's this guy. It goes in x plus 5. So negative 2 in parentheses plus 5 equals 3. Okay, everybody cool? Questions, comments, concerns, or complaints?
Good question. Do we have to, like, example, like, say this was like on a quiz or something, would we have to show work for this or no?
I need that. I need to know where you got 3 from. Tom, you're in class. Oh, it's fine. I need to know how you got 3. So I know, like, in your brain it's easy, like negative 2 plus 5 is 3, Sam. But I need to know what you're doing in your brain. Tell me you're in class. It's fine. So thank you. So if you're ever unclear about is this enough work, then clearly ask me while we're sitting in class, and then on a quiz you can be like, we'll figure out how to do that while you guys are all here. Is this enough work? Okay, and I'll tell you if it is or not. Alright, and then last but not least, x is equal to negative 1. So which part of the function are we going to use?
Bottom.
The bottom. X is greater than or equal to negative 1. So this is the part you're allowed to plug in. X is less than negative 1. Who's trying to come in here? Oh, Ayana got kicked out. Ayana, come back. This guy right here, that's not equal to. It's strictly less than. So you got to be careful, okay? Sorry. Alright, so we plug it into the bottom, we said. And oh, look at, oh, stop it right now, okay? Negative 1 squared is positive 1. So if you would have done this and still said positive 1, that is wrong. That answer's right with the wrong work. Negative 1 squared is negative 1 without parentheses. So you got to have the right work and the right answer. Don't screw it up, okay?
Why would it be negative 1? Is it just because like you're assuming the negative is outside of the number?
Yes, in order for it to be included with the square, it has to be in parentheses.
Okay,
So
thank
the
you.
square is only on the 1. It's not on the negative. This
Okay.
makes it on there. And anytime you plug stuff in, you have to use parentheses. So that's what, it's whatever you plug in gets squared. And we're plugging in negative 1.
Okay, thank you.
Yep. So be careful. Alright. Here we go. Sweet. Yay. Now we get to 18. Now we're about to do, okay, this was some 1800. Piecewise function. Intro. Where's my green marker? Now we're about to do 1800. Okay. Now this is final exam type problem. Test. Quiz. Fun stuff. A, B, C, D. Let g of x equal to x minus 2 over x. Technically was going to do an example before this, but we're going to survive. Alright, that's cool, Sam. That's not bad of a function. We've messed with that kind of function in the first couple of examples. Find and simplify completely. You guys ready for it? Anybody want to take a guess at what it's going to look like? Especially if you were in 1050? Remember those? G of x plus h minus g of x all over h. This is called the difference quotient. Super famous. Okay. And the craziness we're going to do in this class is like, why? Why, Sam? Why do we even have to deal with all that? It's setting you up for calculus. So everything we do here, it's like, our answer is still ugly. It's still just some nasty expression. In calculus, you're going to see why we do all this work. Okay? So it sucks here, but it's going to set you up for calc. It's called the difference quotient. When you add a little bit more fanciness to it, it's called a limit or a derivative. Okay? But you first got to learn the basics. So, in order to do this difference quotient, we got to make sure we know and understand the notation. So I'm going to take it apart. G of x plus h. What does that mean? What does that mean to do? Anybody?
Wasn't more information supposed to be given?
Nope. I got the function and I got the expression.
Okay.
Plug in G.
Okay.
Plug in
Yep.
G.
Plug in g of x. Plug in g of x.
Careful. Plug in. Plug in
Careful.
what?
Plug in x plus h into wherever x is numerical.
Yeah. So the thing that people confuse all the time is, where do we plug in what? What do we plug in where? So somebody was saying plug in g of x, they may have misspoke or they may have meant it. You don't take this guy and plug it into there. Okay? Everything goes into your function. You plug into your function. Plug into function. And this notation means plug in g of x. That's your input. So instead of plugging in 0 or 5 or negative 1, we are plugging in x plus h. We're plugging in crap. Okay? So you plug in this crap using parentheses into the g function. You gotta know what that notation means. And everybody gets thrown off. There's so many variables everywhere. Okay? So we plug in g of x, plug in x plus h into the g function wherever we see x. That's what that means. Okay? Alright, I'm about to do that. It's going to be real fun. X plus h minus 2. So in parentheses, right? All over x plus h. Wherever I see the x in parentheses. That's what it means. I'm going to clean that up. Not much to clean up. I can drop the parentheses because there's no multiplication going on anywhere. There is my g of x plus h. That's the first piece. That's the first expression. That's the first output. Okay. This is my input, x plus h. This is my output. Normally our outputs are numbers, like 5 and 3 and negative 1. It's that crap. Okay. Alright, that's the first piece. The second piece is g of x. Well, what is g of x? What's that equal to?
Isn't that the function?
Yep, that's the original function. Or another weird way you can think about it is plug in x wherever you see x. So it's just itself. Okay? X minus 2 over x. Alright, that's my second input and output pair. Okay? And then h. Okay, do we plug in h?
No.
Nope. Don't plug in h into g because it's not g of h. That means plug in h. This is just a plain old h. So we're going to bring this stuff together. Okay, so we found the pieces. Now we're going to bring it together. And I'm going to rewrite what we're doing. So g of x plus h minus g of x all over h. Lord. So g of x plus h, that is the output that we found. That was x plus h minus 2 all over x plus h. Minus, that's that minus sign, g of x. That was the original function, x minus 2 over x. All over h. But before I move forward, what do I need? What am I missing when I put all this stuff together?
Common denominator.
Oh, not yet. That's moving forward.
Parentheses.
Parentheses. Whether you put them or not, in this case, because it's a fraction, you should have known that you were going to have to distribute that negative in the numerator. Okay, so be careful of that. You're going to have to distribute that negative sometime. Whether you do it now or later, I don't care. But don't forget you're going to eventually have to do it. Is everybody cool with that? Okay, now or later, eventually it's going to get distributed. Okay, so just be careful. Just get in the practice of that. It says find and simplify. So we got some crazy crap on top over h. Like, we can't leave it like that. Okay, and in these problems in general, if you're doing them correctly, okay, we factor out an h at the end. Okay, that's our goal. Factor out an h at the end. That's gonna, it's like, why, Sam? Because calculus, that's why. Okay, that's what's gonna make it simplified. Alright, so some lovely person said, how do you clean up the top? Like, what can you possibly do with those fractions? Well, the only thing you can possibly do with those fractions is get a CD. Okay, so get a CD. You do not clear fractions. Let me write this down. Don't clear fractions. Can somebody say, normally I give candy to my students. Okay, this would be a candy bar moment. Can somebody tell me why you can't clear fractions up here? Like, oh, let's multiply both sides by x plus h and x and clear fractions.
Is it because it's not an equation?
Who said that?
Subtraction? The denominators aren't the same.
Who said it's because it's not an equation?
Alex did. Am I right?
Yes, good job.
Yay!
It's not an equation. That's when we clear fractions and equations. This is an expression, okay? This is an expression. So what do you do with expressions? My lovely person that said get a CD. You get a CD, okay? So here we go. So this is just the top. It's a lot of stuff going on, so I'm gonna keep track. This is on top minus this is on top. Again, eventually you're gonna have to distribute the negative, whatever you decide. What's the LCD? LCD, my lovely people, between x plus h and x.
X squared plus xh.
So it's this times this. So your LCD is x times x plus h. That's your LCD, so you got to be really good with your algebra. Okay. So this guy's missing an x, so we have x plus h minus 2 times x over x. So you're literally getting an LCD. You're multiplying the top and bottom by an x. And then minus, this guy's missing an x plus h. Again, eventually you're going to have to distribute this negative. I'm going to keep these brackets. There's the LCD work, okay? Let me do this. X squared plus hx minus 2x minus, in brackets, x squared plus hx minus 2x minus 2h, in brackets. Because I still have to distribute that negative. So that was all the top. I distribute all the top. All over my LCD. Don't lose the LCD. You know how many times I've said this and people lose it? That's just the top of that fraction. All that mess. I haven't even finished cleaning it up yet. And just FYI, we're new more these Mondays, don't freak out. Alright, let's keep cleaning it up. I got x squared plus hx minus 2x. I'm going to distribute the negative. Negative x squared minus hx plus 2x plus 2h. All over the LCD. Don't lose it. Alright, I can clean this up. X squareds go away, hx's go away, 2x's go away. Oh, that's nice. You have a 2h left on top, assuming I did that algebra correctly. All over, don't lose it. Somebody's going to lose it. Okay. LCD. Okay. This is just the top. Is everybody okay with that? This is 1800. No joke. And these aren't even the hard ones. Sorry. 2h over x times x plus h. All over the bottom. Don't lose either of the bottoms.
Can you move the
Can't
paper?
see that.
Yes. Thank you. So people, they done so much work, people forgot that little stupid h was down there. Okay. Alright. Now that I have one fraction over another fraction, how do I divide that?
Multiply by the reciprocal.
Yeah, good job. So notice I didn't distribute the bottom. That's because I want to simplify and factor, so I want to leave that bottom factor. That's why. Okay. If you did, that's fine. You don't need to, unless you, I don't know why you would, but you want to simplify. Simplifying fractions, and we want to leave stuff factored. Since it's multiplication, you can factor out the h's. So if you're doing these problems right, you're factoring out h. You're left with 2 over x times x plus h. And some people might say, but Sam, there's still h's on the bottom. How did that help us? Calculus. Okay, calculus. That is your completed, simplified expression. That problem, let's stop it right now. Just took 2.5 pages. I mean, yeah, I wrote a little bit big, but whatever. So let's say it took 2 pages. Okay, that's 1800. And that's not even the hard part of 1800. So when you're doing your homework, don't wait till last minute to do it. You see that the problems are going to start to get crazy. You guys have experienced online homework that is just annoying with how you put the answers in, and like, it's just dumb. Okay? So don't wait till, you should never wait till last minute to do homework. Come in for office hours. I'm going to be here tomorrow for office hours. Don't forget. I'll be here tomorrow, 1 to 2. That's what you guys voted. And through the weekend, like I said, you can text me, whatever. I'm usually pretty available. If you need an immediate response, and I'm not answering like emails or something, text me. Like my 9 text. Why do I have 9 text messages? I don't know. Probably my family and friends. Yeah. So you can always text me. Okay. So even though we're done with class today, I still have office hours tomorrow. You still have online homework Monday, Tuesday, Wednesday, Thursday, Friday, right? Every day. And I'm gonna get your hand-in homework up. I can do it tonight. We'll see. I don't know. I don't want to make any promises like I did last time.
Are you gonna say what you want on the hand-in homework?